We are building the first real multi-execution engine blockchain named WasmX. In previous videos, I have showed you WasmX plugins for Python, JavaScript, Golang smart contracts, along with the already known eWasm and CosmWasm execution engines. All of these new languages become first-class smart contract languages, and all of them can collaborate on the same chain. All of this is possible due to our meta contracts, which are core smart contracts in WebAssembly that extend the blockchain and are governed and upgraded by consensus. So you can add any language to the blockchain if you add a meta contract that interprets that language and interfaces with WasmX. WasmX provides the various standards used in practice for executing WebAssembly modules, so you can execute modules built with TinyGo, AssemblyScript, and other compilers. For today's demo, I have 3 contracts, one in Python, one in JavaScript, and one in Golang. The first 2 are interpreted by the respective WebAssembly interpreter module or smart contract, and the Golang contract is compiled to Wasm with TinyGo. And all of them have the same functionality, a forward function and a forward get function. The forward function receives an initial string and an array of contract addresses where the call will be forwarded to. The function makes a log of a computed string and forwards to the next contract address. The forward get function is a query that returns a computed string composed by each of the contracts that are called. And these are the contract sources. For JavaScript, at the initiate function, when the contract is initialized, we store the string JavaScript. And we have the forward function here and the forward get function here. In the forward function, we emit a log with the computed string. And if we look at the doLog function, here we can see that it uses our WasmX SDK. And then it does the call forwarding here, calling the WasmX call method. And in the forward get function, we have the call static function and again the forwarding mechanism, and the return is the computed string. The same functionality is in the Python contract. The difference is that at instantiation time, we store the string Python. And the same for the Golang smart contract. And we store TinyGo. I am now using our dApp for deployment and interacting with the contracts in 3 separate tabs. So this is for the Python contract with the Python source here. This is for the JavaScript contract with the JavaScript source here. And another one for the TinyGo contract, which we will upload from here. And I'm going to deploy these contracts on a local chain, and I have this dApp connected through the Kepler wallet to the local chain that you've just seen. So this is our Python contract. And what we are going to do now is call the forward function with an initial string and then an array of addresses. And these addresses are the addresses of the other contracts. For example, this is the JavaScript contract that we have just deployed. and we have the address here, and then the TinyGo contract here. This is a transaction. And we get our transaction receipt here. We can copy the transaction hash and actually see it on a local explorer. And we see events here that we will look into more detailed in our dApp. And especially we will look at these WasmX logs. So going back to our dApp, we will find the last three events, which are the WasmX logs. And we expect that the first WasmX log was logged by the Python contract, the second one by the JavaScript contract, and the third one by the Golang contract. A WasmX log means that the event was logged from inside an execution environment. So let's look at the attributes for the first log, and we see the contract address, which is the contract address for the main transaction, and this is the Python contract address. So if we do a search on the same page, we will see that this is the address of the contract that our transaction has targeted. Now the next is the log index. This is the first log, and then we have our computed string logged as hex data. This can actually be translated into a string. So this is what we get, our initial string, and then the variable corresponding to the contract that was called, and this is the first contract. The next, we know that this log is of type WasmX. It could be of type eWasm, for example, or of type CosmWasm. And the next is the contract address call, which in this case is the same as the contract address. This will be a different address if the call is an internal call. If we have a call in a call in a call, we will see this changed. The next attribute is the system dependency. And this is the Python interpreter that has received Python source code and its version. So this shows which execution environment was used to execute the contract that logged this event. So each log also contains either the role label, like in this case, or the unique address of this execution environment. And the last one is the module, the Cosmos module, which is WasmX. Now, the second log should be from the JavaScript contract. This is the same address as the Python contract because it is the first contract that was called by the user, index 1, and now this data that we can decode here. And now we have Python and JavaScript. So this is a log made by the JavaScript contract after it has added its own contract variable. Now the contract address call is actually the address of the JavaScript contract, which is this address that we gave here. We are already in an inner call. And the dependency or system dependency is the JavaScript interpreter that has received actual source code and then the version. And now the third log, the address of the Python contract, index 2. We have our data here that we can decode. And now we have TinyGo2. This is the address of our TinyGo contract, which is the second address that we gave in the input. And the system dependency is based on a WASI snapshot preview 1 because this was a standalone WASM module compiled with TinyGo. And now let's test the query, which is forward get. So we get each of the contracts stored variable in the order of the call, from Python to the JavaScript contract to TinyGo. And of course, we can remove one of these addresses, for example, the JavaScript contract. And now we only get Python and TinyGo. And of course, let's copy this in our JavaScript contract UI and also add the Python contract address. And now we have JavaScript, Python, TinyGo. So today you've seen 3 contracts, Python, JavaScript, and TinyGo, collaborate with one another and forward calls in any order. Future demos will only get better and better, and you will see blockchain technology being used in incredible ways.